Okay, we're here today. We're going to start our triangulation by elevation view. So I've got a sketch on the board here, and this is something like you'd have as a shop drawing of a project. So my first step is to draw out a full elevation view. So I'm going to start that. Now, depending on when or what you're given, it might be on center, one of the sides. You might be given a dimension on center, you might be given one outside here, or the long side. But the process is the same regardless. We're going to start with this baseline on the angle. We're going to measure it out to 6 inches. Find center and scribe that center line up. Then if we needed a height at the outside, we could scribe object lines there. That's creating the top. And then we can measure outwards of center, connect it back down. Okay, so that's sort of the process I'm going to go through. So I started with just a arbitrary baseline here, drew my 15-degree angle, measured it out to my 6 inches, drew center line up, measured 2.5 inches either side of center, and now I can connect those points back down. I'm just going to remove off some of my extra line work. If you were drawing this yourself, those would all be construction lines, so there's no need to worry about removing them. And I'll just be left with my clean elevation here. Now I'm going to get some profiles on next. So the profiles again are going to give us a view of what's happening in the depth of this fitting, or what the shape looks like even. Okay, so there's our elevation view with profiles on it now. We've got a lower profile for the square end and a half round for the top. I always want to label my drawings, and you want to do the same. It's just an ability to be able to track things, to know where you are at any given point. Okay, so I'm going to label mine, and again, I suggest you follow the same as I always do numbers for something round, and I do letters for something square or rectangular. And that allows me to see what's what, which end I'm dealing with. Okay, so let's go ahead and draw in those element lines now. And I'm going to connect everything, knowing the shape. I'm going to come down to the left-hand corner of the square from the left-hand corner of the round, or the left-hand side of the round, I should say. And everything on the right-hand side of the circle will go to the lower right. Okay, so now we have what we'd call a complete elevation view. We have the original drawing that we did there, and then we have profiles and element lines added to it. So we're ready to begin our actual triangulation now. So I'm gonna remove our elevation view here, our shop drawing, just because I'm gonna need the room for the pattern. We won't need that anymore, but you'd still have it if you had a shop drawing or something. And we're gonna start our pattern. So squared rounds always start the same way. It doesn't matter which process you're using, plan view or elevation. But we're going to start with baseline AB, which is a true length in our elevation view. We drew it out to 6 inches, so we know that's true. So let's start that here. And I'm going to label that. AB. Now this would be the back side of the fitting that we're doing, so we're not doing the front here, we're doing the back, because remember we always want to lay everything out to the inside. And when we're looking at this one, if we thought of AB as being out here, and we're looking at A on the left hand side, we'd be looking at the outside of the pattern. If we think of the back side of the fitting, A would be on the left for the inside of the pattern. So that's what we're going to develop, and then we're going to flip it so that we get the inside for the front pattern here. So again, we're working the back side. So we have our baseline AB, and the only thing that connects those two to make a triangle is point 4. So we see this triangle here, and there's nothing else that connects AB to make this triangle. So the first point we have to develop is point 4 there. Now we're using the process or method called difference in profile. And what we're doing is comparing all these profile heights to the profile heights down below. And we only have the one down below. It's the same on both sides. But this is the comparison we're making. Because we know this fitting is coming out that far, and that everything's coming to that corner, it's out here. And that's a representation of that. So we take profile 4. I pick up that length there. And I'm going to bring that down to the bottom, starting from D. I'm going to shoot it inwards. And I get to here. Okay? And if you want, you can label that. Let's label that 4, so we know that's profile 4. So what it tells us is at this point here, it's leaning so far. And at this point here, it's leaning so far. And that's the difference. That's the actual lean of that line. Okay, so next thing I'm going to do, because it's all about working a true length diagram, but in this case, we're doing it right on our elevation view instead of making a separate diagram. My next step is to take the length of the element line, and I'm going to draw that downwards. Now all I'm doing is transferring the length of that line, and I transfer it downwards here. Okay? So now you can see I've got a 90-degree corner, just like I would in any true length diagram, and I have a difference of profile on one side, and I have the length of the element line from the elevation view in the other. So now if I pick up that true length as the hypotenuse of this line, that's going to be the line I want to use in my pattern. Just a slight growth there. And I swing that from point A. Just like so. We're going to work true length of line B4 now. So again, I'll pick up the profile line, take it down from the outside, from C, tick it off, then pick up the length of the line in the elevation view and swing that down. Again, I'm just transferring a length from here to here. I could transfer that length anywhere into a true length diagram. But I have this 90-degree corner pre-built. So I use it. Why not? So pick up that hypotenuse, that's our true length. I come over here from B this time, swing that across, and there's point 4. Again, I'll remove some of my extra lines here that I don't need. Yours again are construction lines, so no need to erase anything. But I want to be left with just that point, so it's clear. Okay, so now we're gonna work one side of the fitting because there's no symmetry here anymore. You can see it's not the same left to right. So I'm going to work all the left-hand side here. So I'm going to take line A3 and bring it down, and profile 3 and bring it down. Again, the hypotenuse is my true length. Swing that one on the left side of 4 from A. To finish that, I need a step off. And just like we've done before, I'm going to pick up 3, 4 here and swing it from 4. There we go. So now that's point 3. While I'm here and I still have this step off set, I'm going to swing another step off, and it's kind of going out of order. But I'm preset here, so why not? Save some time. So this is now working towards point 2. So again, I'll pick up line 2, bring it down, profile 2, bring it down, and the hypotenuse becomes point 2. Okay. Last one on the left here we see going this way is point 1. So same thing, I'm going to take up line 1 here, A1, and bring it down. Now we have 0 profile up top here. Okay, and this is one point where people get caught up. 0 profile at point 1, full profile at point A. Okay, we still have this full distance here. So we still have to do a comparison. We still need to find the difference. And if I take this full profile and minus nothing off of it, it's still this full length. So my true length becomes from point D all the way out to the profile. And you'll notice it's a key component here that every line we go upwards with needs to be developed as far as the true length. Okay, so every single one, 4, 3, 2, 1, we had to put it into a true length diagram. And that was done right here, but it's still a true length diagram. Now from what we know previously, we know when we drew this elevation view that the outside edges are always true lengths. Okay, but we can't recognize A1 as a true length because it has no profile, but it has full profile here. A1 is still coming out towards us. Okay? But D1 actually wraps right along that, and that would be right over top of line A1. So there's actually 2 lines here, okay, represented in that elevation view. But only one of them is true length. And the one that is true length is actually D1. And even though D is out here, it's still, when that wraps in, that's the center point. Okay, at A1, it's going from center of the round all the way to the outside corner or the back corner. D1 is going from center at the top to center at the bottom. And that tells us it's just straight up and down. It's not leaning anywhere. So for my next line, when I start working these wings, I pick up A1, and that actually represents the true length of line D1. And where I'm trying to get to now is point D down here. So I flip my dividers around and I swing from 1 coming downwards. Now, good way to remember it is the line that you swing downwards is the true length in the elevation view. Remember we said everything up top here we had to develop a true length for. But when we swing downwards now, we're picking up the true length right from the side, right from the elevation view. So I got that one, that's D1. Then I need to go from A to D. And again, our profile is a true length. We can take lines off our profile at true length. And I swing that from A. And that becomes point D. Now our checkpoint for squared around is always these wings here. And again, same as when we did plan view development. I want to see that that corner is exactly 90 degrees. And if I've done everything correctly, that corner will be a 90. I can put a square in there and check it. And that looks pretty 90 from my point here. Okay, so that's our one side done. And now we're going to have to work out 5, 6, 7 and point C going the other way. So same techniques. We're going to use difference in profile still. Nothing changes. We're just going down the left-hand side now. So I already did B4. Now I'm going to B5. So let's pick up the length of the line from the elevation view. Swing it down. Pick up profile 5. Bring it down. And the true length here now is the hypotenuse. Come to B. Take a step off. And there's 5. Again, I still have my step off, so I'm going to do one more. Okay, B6. Profile 6. And hypotenuse is the true length.